Hi there, welcome to my channel MathWeb. In this video, I'm going to explain question number 4 from Pearson Edexcel A-Level exam for Mechanics 1. This exam is taken in May-June session year 2023. Paper reference code is WME01/01. Figure 1 shows a beam AB of mass m kg and length 2 meters suspended by two light vertical ropes. The ropes are attached to the point C and D on the beam, where AC equals to 0.6 meters and DB equals to 0.2 meters. The beam is in equilibrium in a horizontal position. A particle of mass pm kg is attached to the beam at A and beam remains in equilibrium in a horizontal position. The beam is modeled as a uniform rod. Given that the tension in the rope attached at C is 4 times the tension in the rope attached at D, use the model to find the exact value of P. This question is of 7 marks. Here, this thing is to be noted that the rod is uniform. Whenever the rod is uniform, the weight of the rod acts at the midpoint of this length. If the length of this rod is 2 meters, the midpoint will be here at 1 meters, and the weight of the rod acts at this point, at the midpoint. Okay, this point is very important for uniform rod. Let me draw all the forces here in this diagram. Because this is the midpoint is 1 meter away from A and 1 meter from B, that's it. And weight of the rod is acting vertically downwards. We can say this is mg. Weight is, because mass is m, so we can say weight is mg. And other weight that is acting at point A, look here, that weight is pm kg. So weight of pm kg will be pmg. So we can draw the weight force here. It will be pmg. Pm is the mass, so weight will be pmg. Okay. And another point to be noted, the tension, look here, tension at C is 4 times. If the tension at C is 4 times the tension in the rope attached at D, so it is 4 times. The tension at C is 4 times the tension as compared to D. If the tension at point D is T, let's say this is the tension in D, we can say it is T, and C will be 4 times of this one, 4 times T. Hopefully you understand why it is 40. It is given in the question that tension acting at point C is 4 times as compared to tension acting at point D. That's it. So these things are given. We know that it is acting at the midpoint. If it is acting at midpoint, this length will be 1 meters for sure. It is 0.6, and we can find out this distance as well. This will be 0.4 meters for sure. Okay, and same way you can find this distance from here to here, because from this midpoint, that is M, from M to B is 1. So this is 0.2. The remaining part from 1 will be 0.8 meters. Okay, so this will be the diagram here. As the system is in equilibrium, we know that for equilibrium the upward forces equals to downward forces. This point is very important. When the system is in equilibrium, we can say the upward forces equals to downward forces. We can use this one, upward as positive. So what are the forces that are acting upwards? That is 4T and T. So we will add them together. 4T plus T should be equals to the downward forces. They are pmg plus mg. There are 2 forces that are acting downwards. So you can get the value of T from here. That will be pmg plus mg. You can divide both sides by 5 to get the value of T. So it will be pmg plus mg divided by 5. So this is the tension T. But we need to find the exact value of P. So here we could apply the law of, the other rule for equilibrium. The clockwise moment should be equals to anti-clockwise moment. So you have to consider a point where we can take the moment. That is your choice, which point you want to take the moments. You can take at point A, at C, at M, whatever, no problem. You can choose any point. So here I'm choosing point C. to take the moments. You know what is the rule for moments? First of all, you have to choose the pivot where you are taking the moments. So here the pivot point is C. We can say taking moments about C. So what is the definition of moment? We multiply the force with the perpendicular distance from the pivot. Look at this point C. We will ignore this force because there is no perpendicular distance here, so we ignore the same where you are taking the moments. We ignore that force, okay, because there is perpendicular distance is 0, no need to take it. So now 3 forces left over there. You know, we will ignore this one. There are 3 forces, 1, 2 and 3. So which forces are producing clockwise rotation about C? If you notice that this force is producing clockwise rotation. If you take this C as the pivot, this force is moving like this downwards, so it is clockwise rotation. And the only one force that is producing clockwise rotation, that is mg. And what is the perpendicular distance of mg from this pivot? That is 0.4. So you can multiply mg with 0.4 to get the clockwise moment. This is the clockwise moment. There are 2 other forces. Look here, this force about C is producing anti-clockwise this way. This one, this way is anti-clockwise and this way is clockwise, you know that. And about point C, this force is producing anti-clockwise rotation. So these 2 forces are producing anti-clockwise rotation. That's it. What is the rule for moments? Clockwise moment equals to anti-clockwise moment. So clockwise rotation, this force is producing mg. What is the perpendicular distance? That is 0.4. So mg will multiply by 0.4. So this is the clockwise moment. And anti-clockwise moment, there are 2 forces. One is pmg, and its perpendicular distance from C is 0.6. You know, from here to here, the distance is 0.6. So you can write here mg, pmg multiply 0.6 plus there is another force that is producing anti-clockwise rotation, that is T. And what is the perpendicular distance of T from C, from here to here? Look here, this is 0.8 and 0.4. So if you combine them together, so it will be 1.2. 0.8 plus 0.4 is 1.2. So T will multiply by 1.2. That's it. Now in the next step, what you will do, we will plug the value of T, this one here, okay, and now everything will be in terms of pmg. So we will get rid of T from here. Just plug in the value in the next step. So we get here mg, pmg 0.4, pmg 0.6 plus T, that is pmg plus mg divide by 5. This is the value of T, and right here 1.2. The easiest way to solve this type of question, whenever you find a fraction here, multiply by the denominator, highest denominator. It is the easiest way to solve these type of questions, because denominator is here 5. This is my way of doing. You can simplify that in your way, no problem. That is your choice. But my way is this one. Whenever you find a denominator, highest denominator there, get rid of that denominator by multiplying every term by 5. Multiply by 5. Every term will be multiplied by 5. This 5 will multiply here. We get 0.4 multiply 5 will give you the answer 2. So it will be 2 mg. 5 multiply 0.6 will give you the answer 3. So it will be 3 pmg. When you multiply 5 here, so you will get rid 5 from this fraction. That's it. And here you need to do just only multiply this number with these 2. That's it. Okay. So it will be 1.2 pmg plus 1.2 mg. If you notice that mg is everywhere, we can cancel, we can get rid of this mg from all of them. That's it. You can cancel them and then we can simplify this one. So here it left with 2, and this is 3p plus 1.2p plus 1.2. Okay. Now just move this value to left side. So 2 minus 1.2 will give you the answer 0.8. And 3 plus 1.2 will be 4.2. P implies that we get the answer of P from here by dividing 0.8 by 4.2. You get the answer as fraction. Better you write as is, like in fraction, if you want to get the exact value of P. So 0.8 divided by 0.8 divided by 4.2 give you the answer 4/21. So this is the answer for the first part. First part is done. Let's move on for the next part. The particle of mass pm kilogram at A is removed and replaced by another particle qm at A. The beam remains in equilibrium in horizontal position but is now on the point of tilting. It is still in equilibrium but it is at the point of tilting. Using the model, find the exact value of Q. Almost we have the same diagram. So instead of this PM, we will replace this point, this weight with QM. We will use the same diagram, just instead of PM, we will use here QM. So it will be QMG, that's it. This is the only change, okay? Now, the second thing, because of this weight, it is at the point of tilting. If it is at point of tilting, so this you know, there will be no more this tension here because it will tilt this way, but still it is in equilibrium. At the point of tilting, the tension at D will be 0. So tension at D point will be equals to 0 at point of tilting. This is the only difference in this part, okay? So you will consider this part as tension 0 for D. That's it. So for the last part of this question, what we'll do, at point of tilting, tension acting at D will be equals to 0. Again, we will take the moments about C, taking moments about C. Let's move back to the figure. Now this tension, this force is ignored and you are considering this one. Look at this figure. We ignore this force as well because we are considering this C as the pivot. Okay, we will ignore this force. Now only two forces left over there. One is QMG, and QMG is producing anti-clockwise rotation about C, and MG is producing clockwise rotation about C. Okay, so we will apply the same formula. Clockwise moment equals to anti-clockwise moment. So this force is producing clockwise. Mg will multiply by 0.4. We will write here mg multiplies 0.4 equals to qmg, that is producing anti-clockwise, and the distance of this one is, from C is 0.6. This mg could be cancelled from both sides, and this 0.6 will divide to the other side. We get the answer as 0.4 divided by 0.6, and this will be q, and q will be equals to 2/3. So this is the answer for second part of this question. Hopefully you understand it. Let's go back to the last part of this question, number 4. State how you have used the modeling assumption that the beam is uniform. I told you earlier, if the beam is uniform, the center of the mass is at the middle. We can write here the center of the mass is at the middle. Center of the mass means the point where the whole weight of that object acts upon. That is the midpoint, okay? The center of the mass is at the middle. That's it. So this is the answer for the last part of this question. Question number 4 is done. If you have any question, any doubt in this question, please write in the comment box. Thank you.